For this problem, we're going to test a polar equation for symmetry with respect to the pole, the polar axis, and the line theta equals pi over 2. Testing the equation r squared cosine theta equals 5 for the three symmetries that we mentioned. We're going to start by checking for symmetry around the polar axis. To check for symmetry around the polar axis, we're going to replace theta with negative theta and see if we get the same equation back. So we'll have r squared times the cosine of negative theta is equal to 5, which gives us r squared cosine theta equals 5, since cosine is an even function. This is the same equation that we started with, so there is symmetry with respect to the polar axis. Next, we're going to check for symmetry with respect to the pole. To check for symmetry with respect to the pole, we're going to replace r with negative r and see if we get the same equation back. We're going to get negative r quantity squared times cosine theta equals 5. This gives us r squared cosine theta is equal to 5. This again is the same equation that we started with, and so we have symmetry with respect to the pole. Third symmetry we need to check for is symmetry around the line theta equals pi over 2. To check for this symmetry, we're going to replace theta with pi minus theta and see if we get the same result. So we're going to have r squared times the cosine of pi minus theta equals 5. That's going to be r squared times the cosine of pi times the cosine of theta minus plus the sine of pi times the sine of theta is equal to 5. We'll get r squared times negative cosine theta is equal to 5, or negative r squared cosine theta is equal to 5. This is not the same equation that we started with, so this fails our test. However, all we can say at this point is that it may or may not be symmetric around the line theta equals pi over 2. Note that because we found symmetry around the polar axis and the pole, it actually can be shown that we must have symmetry around the line theta equals pi over 2 as well. So in this case, we will have all three symmetries.